Yes, the withstand rating of a non-fuse disconnect or transfer switch is an important factor to consider when selecting the appropriate device for a particular application. The withstand rating indicates the maximum fault current that the device can safely endure without sustaining damage. If the calculated fault current at the device's intended installation point surpasses its withstand rating, it's crucial to avoid using that specific device. Instead, a fuse disconnect switch equipped with a higher withstand rating should be employed. Failing to adhere to this guideline can lead to device failure and potentially hazardous situations. The primary reason for this precaution is that exceeding the device's withstand rating during a fault event can compromise its structural integrity, leading to damage and potentially creating a significant safety risk. It's also essential to distinguish between the withstand rating and the interrupting rating of a device. While the withstand rating defines the maximum fault current a device can endure, the interrupting rating specifies the maximum fault current the device can safely interrupt. A device with a high withstand rating may not necessarily possess a correspondingly high interrupting rating. Therefore, it's imperative to select a device with a withstand rating that meets or exceeds the calculated fault current at the device's installation location. This ensures that the device can safely withstand fault currents without failing. The consequences of ignoring the withstand rating can be severe, potentially leading to equipment damage, electrical fires, and even personal injury. When performing fault current calculations, several factors must be considered. Firstly, the available fault current from the utility or power source needs to be determined. This information is typically available from the utility company or can be calculated based on the transformer impedance and voltage levels. Secondly, the impedance of all conductors and equipment in the circuit must be taken into account. This includes the impedance of cables, transformers, switchgear, and other devices. Thirdly, the contribution of any motors or generators connected to the system should be considered. Motors can contribute to the fault current during a fault event, and their contribution needs to be factored into the calculations. Once all these factors have been considered, the total fault current at each point in the distribution system can be calculated. This information can then be used to select appropriately rated disconnect switches and transfer switches. It's important to consult relevant standards and codes such as the National Electrical Code, NEC, to ensure compliance with safety regulations and best practices. NEC Article 430 addresses motor circuits and provides guidance on selecting motor disconnects and overcurrent protection. When selecting a disconnect switch for a motor circuit, the NEC requires that the disconnect switch be rated to interrupt the motor's locked rotor current. The locked rotor current is the current that the motor draws when it is first started. It is typically much higher than the motor's full load current. The NEC also requires that the disconnect switch be horsepower rated to match the motor's horsepower rating. This ensures that the disconnect switch is capable of safely interrupting the motor's current. In addition to the NEC requirements, it's also important to consider the withstand rating of the disconnect switch. If the calculated fault current at the disconnect switch location exceeds the withstand rating of the switch, then a fuse disconnect switch with a higher withstand rating should be used. Fuse disconnect switches provide both overcurrent protection and fault current protection. The fuses in the disconnect switch will open and interrupt the circuit if the current exceeds the fuse rating. This helps to protect the motor and the electrical system from damage. When selecting fuses for a fuse disconnect switch, it's important to choose fuses that are properly sized for the motor. The fuse size should be based on the motor's full load current and the motor's starting characteristics. The NEC provides guidance on selecting appropriate fuse sizes for motor circuits. In some cases, it may be necessary to use oversized fuses in a fuse disconnect switch. This is often done when the motor has a high starting current or when the motor is subjected to frequent overloads. However, it's important to ensure that the oversized fuses do not compromise the overcurrent protection of the motor. The motor starter provides overcurrent protection for the motor. The motor starter includes overload relays that will trip and disconnect the motor from the power supply if the motor is overloaded. The overload relays are typically sized to protect the motor from damage due to overloads. The fuse disconnect switch provides fault current protection for the motor and the electrical system. The fuses in the disconnect switch will open and interrupt the circuit if a fault occurs. This helps to prevent damage to the motor and the electrical system. When selecting a transfer switch, it's also important to consider the withstand rating of the switch. Transfer switches are used to transfer power from one source to another. For example, a transfer switch may be used to transfer power from the utility grid to a generator during a power outage. The withstand rating of the transfer switch should be greater than or equal to the calculated fault current at the transfer switch location. This ensures that the transfer switch can safely withstand fault currents without failing. Transfer switches are available in a variety of configurations, including manual transfer switches and automatic transfer switches. Manual transfer switches require an operator to manually switch the power source. Automatic transfer switches automatically switch the power source when a power outage occurs. Automatic transfer switches are typically used in critical applications where it's important to maintain power continuity. When selecting a transfer switch, it's important to consider the application requirements and the available fault current. The transfer switch should be rated to withstand the maximum fault current that could occur at its location. The transfer switch should also be compatible with the power sources that will be connected to it. In addition to the withstand rating and interrupting rating, there are several other factors to consider when selecting disconnect switches and transfer switches. These factors include the voltage rating, the current rating, the enclosure type, and the environmental conditions. The voltage rating of the switch should be equal to or greater than the voltage of the circuit that it will be connected to. The current rating of the switch should be equal to or greater than the maximum current that will flow through the switch. The enclosure type should be appropriate for the environment in which the switch will be installed. For example, a switch that is installed outdoors should have a weatherproof enclosure. The environmental conditions should also be considered when selecting a switch. For example, if the switch will be installed in a corrosive environment, then a switch with a corrosion-resistant enclosure should be used. By considering all of these factors, you can select disconnect switches and transfer switches that are safe, reliable, and appropriate for the application. In summary, firstly, always consider the withstand rating of non-fused disconnects and transfer switches. Secondly, ensure the withstand rating exceeds the calculated fault current at the installation location. Thirdly, fused disconnects offer higher withstand ratings for increased protection. Fourthly, oversized fuses, if used, should not compromise motor overcurrent protection. Fifthly, motor starters provide primary overcurrent protection for the motor itself. Sixthly, transfer switches must also have adequate withstand ratings for fault currents. Seventhly, consider voltage, current, enclosure, and environment when selecting switches. Ignoring these considerations can lead to unsafe conditions and equipment damage. Remember that the information provided here is for general guidance only. Always consult with a qualified electrical engineer or contractor for specific applications and to ensure compliance with all applicable codes and standards. Fault current calculations can be complex and require specialized knowledge. It's important to have these calculations performed by a qualified professional to ensure accuracy and safety. Additionally, regular inspection and maintenance of disconnect switches and transfer switches are essential to ensure their continued safe and reliable operation. This includes checking for signs of damage, corrosion, and loose connections. Any problems should be addressed promptly to prevent potential hazards. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. Always prioritize safety and consult with qualified professionals when working with electricity. Remember that electricity can be dangerous, and it's important to take all necessary precautions to prevent accidents. Regularly review and update your knowledge of electrical safety practices and codes to stay informed and ensure compliance. This will help to create a safer working environment and prevent electrical hazards. Proper selection and installation of disconnect switches and transfer switches are critical components of a safe and reliable electrical system. By paying attention to the withstand rating and other important factors, you can help to prevent equipment damage, electrical fires, and personal injury. Always prioritize safety and consult with qualified professionals when working with electricity. The NEC is a comprehensive set of standards that provides guidance on electrical safety. It's important to be familiar with the NEC requirements and to follow them carefully. The NEC is updated every 3 years, so it's important to stay current with the latest edition. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It's important to be aware of these requirements and to comply with them. Electrical safety is everyone's responsibility. By following safe practices and consulting with qualified professionals, you can help to create a safer working environment and prevent electrical hazards. Remember that electricity can be dangerous, and it's important to take all necessary precautions to prevent accidents.